Hello and welcome to Loughborough University's Institute of Advanced Studies. I'm Professor Ksenia Chmutina and I'm the director of the IS. And it's my absolute pleasure to welcome Dr. Achituv Cohen to Loughborough University. Also welcome to those of you in the room, to the International House, and those of you who are joining us online. The IIS is the hub of Loughborough University where we have the most, in my opinion, interesting conversations and discussions. And this is where we debate and discuss the things that are really, really important to our society, to our life. And today's topic about the sustainable urban mobility is indeed a great example of that. Just a couple of house rules. As always, we are running this seminar in a hybrid mode. So for those of you online, please post the questions in the Q&A bit at the bottom. We're monitoring the questions, and there will be time for you to ask the questions. For those of you in the room, you will have an opportunity to ask the questions and also enjoy the lunch and chat to Achituv after all. The presentation is recorded and will be released as a video on YouTube and also as a podcast just later. Today, tomorrow, in the next few days. Tomorrow. But we're not publishing the Q&A, so that's kind of a safe space to discuss anything that we would like to discuss. Without any further ado, I would like to pass to Dr. Achituv to introduce Dr. Cohen.
Thank you very much, Ksenia, and huge thanks for the Institute of Advanced Studies for letting us this opportunity. So yeah, I'm happy to introduce Achituv, Dr. Achituv Cohen. He will talk to you about walkability and he will explain what does it mean, walkability. I just want to give maybe a brief historical perspective how we come to this subject. So since already maybe 20, 30 years, we are trying to reverse our city from the modernist planning, which was all about car centers, to make them more walkable. And I want to cite here a report which was published a month ago, a report from the Royal Town Planning Institute, the big British organization focused on planning. And they published this report shows that most of the new towns development in last 20 years are basically not walkable. Despite this notion that we all know already for quite a long time, how walkability benefits us. But one of the main points here was that, especially in the last 10 years, it was kind of stagnation in this walkability process. So basically, we do know what it is very important, but we still don't have enough tools. We don't know how to measure it. We don't know how to implement it. And Achituv's talk will be about this important point, how we can make it, make some practical tools to measure it. And maybe I would like to finish with kind of personal note here. It's a special academic parental moment for me because Dr. Cohen was my first PhD student, and I am really happy to see him staying in academia and being an assistant professor. So it's a great pleasure for me.
Perfect.
Thank you.
So I'm really glad to be here and see you all in here. And first, I want to say thank you for the Institute of Advanced Study and Dr. Achituv that allow me to share with you my research, my knowledge that come up from this research. Just a bit of background. Most of my studies I did in Technion University in Israel, and then I did 2 years as a postdoc in Santa Barbara, California, in Geographic Department, and today I'm the Ariel University in Israel. And I tried to talk about my main goal today based on knowledge and experience that I have from my last research. And let's start. So the first things I would like to define is what is walkability. So basically, walkability is how much the environment an area which could be neighborhood, which could be city, is friendly to walk. And as you can see from here, there are many parameters or factors that can improve walkability or encourage walkability or other way around. And we're going to talk about it later on every factor. But why walkability matters? Why walking matters? So the research have already shown that there are many reasons why it matters. From it's improve our health, it's improve the social and emotional benefits. And simple, you just need to go out and walk. There is no any other things you need to learn in order to walk. Also, it's can improve the air condition, the air pollution, and the traffic jam, and also improve our mental health or our mood. For example, I can tell you every time I feel stuck in my research, in my room, can't find the solution. So I'm just going out for 5-10 minutes, just it. And then, or I will find a way to solve the problem, or I will find another way to solve the problem. I mean, not to solve, another approach to that I didn't think before, just by walking. So let's try to, before going or deep into the subject itself, let's understand how often and how long do people walk today. And maybe let's do a short test with you. And I would like to know about, if you want to share with me, how many times a week, how many times per week you walk less than 1 mile, or taking trip that less than 1 mile, which is like half an hour, less than half an hour. And so let's try this by let's try to calculate it and put it in Excel file and see the result per year. So how many people walk 1 a week, one per week, one trip per week that is less than 1 mile? Only one. Okay, so per week 1, let's, okay, 2.
2 times, right?
Yeah.
Yeah.
So we have 1, 2, then we have how many 2 times per week? No, 3 times. 4, 5, 6. 6. Okay, so 6. How many times? How many people say 6? So we have 2, 4, 5, and it's me also. So it's 6. So it's okay. Let's say 6, 7. Okay, 7 twice 7. We have 7 and 8, 9, 8. Okay. More numbers? No. So let's see how. No, that's not the 8. Now let's see how many times per week, per year. We're taking this number. Now it's. Okay. See if they make sense. Yes. So in average, this group walking about, let's say, 367 trips per year, which is with trips that are less than 1 mile or less than half an hour. I have another.
You need more than half an hour.
So there is another. Actually, there is another option here to do the same test on more than half an hour.
But everyone walks less than half. Every time you go out the door, you're walking on a trip, right?
Mm-hmm.
Like for me to come from here from the school, that's less than a mile. And if you talk about that, then I must do 30 of those a week.
Okay.
You see what I mean? It's like, what do you mean by less than a mile? Is 200 meters a mile? Like less than a mile? Yes. But people do that all the time. So I was a bit confused.
Yeah, okay. Yeah, of course. So I can understand your point. Let's leave it for now. I would like to compare this number we saw here to the number that to result from the
Oh, yeah, you saw
well, this picture.
this one.
This one.
No.
Okay, so let's try to compare. So it was like 366 trips per year, and here we see the numbers based on the National Travel Survey in UK, which calculates the number of trips that less than a mile, which is in the top graph, and more than a mile, which is in the bottom of the graph. And anyway, our number is much more than 184. And what we can learn from this graph. So basically we can see there is no clear trend that people walk more or walk less. The only clear phenomena we can see from this graph is the coronavirus. Let's see if I can. So, no, okay.
Oh, you
yeah.
wanted to use the mouse too.
Okay, let's see. No, never mind. So yeah, I can use this one. Okay, so here this is the COVID. This is the beginning of the COVID. So we can see more trips that are more than 1 mile, and less trips that are less than 1 mile. This phenomena we can see as well in here, which count the number of miles per year of trips that are more than 1 mile and less than 1 mile. So we see a jump in the results because of the COVID, and then we start to going back to our normal behavior. So that's about how long and how often people walk. And another question, and I'm not going to ask you this question, what are the purpose of walking trips? So again, the same survey showed the result between 2019 to 2023. And what we can see here, first, most of the people walking, the purpose of walking is for pleasure, for sport. We also had some jump in the 2020, at the beginning of the COVID, and going back to our normal behavior. Another big population that use walking is, I guess, education student. On the other hand, at the end of this bar, we can see actually the business, working for business, or daily commute to work. There are many reasons why people don't use walking as a mode for work, for walking to get to their work. But that's like big picture on this and on the patterns about walking here in the UK. And the next question I would like to ask you is, can we change the environment to encourage walking? And in this photo, in this image, you can see this is for my hometown, which I used to run here every time I go to my walk. And it's like very lovely environment. See the wide pavement, clean, good surface, good quality of surface, a lot of trees, lights, decoration. But I can promise you that almost every time that I was there, morning, afternoon with the kids, evening, it was like that. Like almost no one in there, which means that spend money on infrastructure, it's not enough. We need to see the walkability or walking behavior should include many factors. And what are those factors? So here we have the main key factors, 6 factors that I'm going to talk about each one of them. And before I'm going to talk each one of them, I would like to to share with you my current goal, which is if I have all the factors that somehow affect walking, and I have also pedestrian movement data about the pedestrian movement, about the pedestrian volume, however you call it. So my goal is to take those rectangle and try to understand how those factors or combination of those factors affect pedestrian movement. And remember, this is 6 factors, and each factor is actually list of some component. I just want to know that one component, it doesn't have to be just related to urban design. It can be also related to safety and security. For example, let's say the lighting is part of the urban design, but it can affect our safety and security. So even if I put some component or some sub-factor in one factor, it could be in others as well. So let's see what are those or these components. So about urban design and infrastructure, so we decided to focus on those five parameters or features, and based on current research, so sidewalk width is basically the most important one, apparently, from all among all of those that here. Lighting and building height, they are part of urban design, but on the other hand, they can affect our security, or they can impact our security or feeling of our safety when we walk. In addition, we have the land use, and today more and more areas become a mix of land use that apparently promote walking, and also a street slope. Regarding safety and security, we would like to look on the car pedestrian accident rate and crime rate. And then we have urban amenities, a list of amenities. We found that they could impact our walking. Some of them is the number of, and specifically for park, so we look on the proximity to the park, which means we don't look on a given street if there is a park alongside, but how much is far from the closest park. And then we have urban network structure, and okay, so most of the urban network structure are measured by centrality measure or space syntax measure or topology measures, and we look on specific two measures, betweenness and closeness. In closeness, every node, which stands for intersection in our area. So in the closeness, we calculate this the sum of all of the shortest path between a given node to other node in the area. So if this number is low, so this means that the closeness here is higher, and in betweenness we measure how many times a node or a link, which is stand for the street, is part of shortest path of other node between other nodes or between other links. And about line of sight, I would talk about it later because this is work that I did with Dr. Asia. So I will have some other slide about line of sight. And then we have the environmental and social context, like greenness, air quality, weather, and temporal variation. When we talk about temporal variation, so we have the time in the day, weekend via weekdays, and also seasons. Seasons relate also to weather. So it's quite, there is some kind of correlation between them. Sorry. Let's see. Okay, great. And lastly, is demographic, like age, like socioeconomic level, residential density. All of those, all of those factors is also something we want to add to our model. So great, we know what are the factors, and the next question would be, okay, I know I know what are the factors, but how can I take this factor and add them as part of my model? So let's say this is not a city, it's Tel Aviv. So I need to take all of the street in the city, and so now every street would be represented by its geometry. So now I have for each street, I have its geometry, and now I link each geometry with all of the factors that we defined before by doing some simple calculation. Let's say for a given street, given street which is geometry, we look on the number of education places. Okay, so and all of this information I put into the table. So eventually, for each street, I have a list of features, which is stand for the component we talked before, and the values are the measure for each feature. Okay, so we now have all of them. We have like a picture of what we need, but I need some resource for all of this data. I need I need data about the urban environment factors, characteristics. I need a street network, a reliable street network that I can use. And finally, I need I promise that I need also pedestrian movement data. Without it, I can't really check if my model is reliable or not. And the data or the sources I'm going to share with you is based on my previous research. So for urban environment characteristics, first I'm going to OpenStreetMap, because OpenStreetMap is a global project that all of the data in OpenStreetMap are shared by contributor. Contributor could be people, could be private companies, private or organization, everyone with this interest. Let's see an example. So here is Lavro in OpenStreetMap, and I think the main benefit of using OpenStreetMap that all of the data that you see here, I can actually download to my computer and then analysis or query or edit the data. So, for example, if I look on this high street, so can see many features, and for each feature, I can see more tags, which consist of a key and value, and all of this data can be downloaded into my computer and used for further analysis. Another example is using municipality data, which is tend to be more accurate than the data in OpenStreetMap, but it's not always open to the public. Some municipality just allow you to see the data, like Google Maps, or some give you some limitation. So in Tel Aviv, for example, everyone can get to their system and download the data for free without any other restriction. Just okay, like it in English. I can select the layers. Okay. Okay, so it's here. So you can see the list of layers I can download. Just click on the plus, and you can see here any different layers. Just clicking on this disk, choose the area, and then I can download the data very, very easily. But as I said before, most of the cities are not give you this access for data, as Tel Aviv does. Okay. And of course, we have census data, and I think regarding the census data, so most of the country give access to the census data. In United States, they give you access not only to the census data, but also all the geographic boundaries that related to the census data in different scale, from a block to neighborhood and so on. And they also provide you with API, so you can just using some code and you can get all of the data you need without any manual downloading. But sometimes GIS or GIS platform or dashboard is not enough. There are some information we cannot get from there, or we don't have an access. We don't have access. For example, let's say I want to calculate the light by count the number of light poles, or I want to calculate the width of sidewalks. So today, the most popular way is using image from aerial imagery or from satellite or street view imagery, and then using deep learning or attention mechanism to get all the information about those object or other object. And I think today not today, but the main difficulty here is one, get very high resolution of images. Otherwise, it will be very hard to get the precise width of sidewalk, for example. And second, you need to train your model. And sometimes you have training data, but sometimes not. And then you need to collect by yourself the training data. But on the other end, you can use model that already does the work for you. And I saw yesterday one of the students of ASIA that showed me a model that know how to detect object. So someone else did the work, so just put in my data to the model, and I got the obstacles. And other ways is to use remote sensing, and we specifically use remote sensing or to calculate to get greenness. That was work we did in colleagues from Houston. In that case, we tried to find if there is any correlation between greenness to the recovery of people with brain injury. So we had an access to this image, which is based on remote sensing, and every pixel, which is 30 meters or 30 meters, the color of the pixel is the percentage of greenness in this pixel, which is a zone in the ground. So by using remote sensing, we can calculate other factors. In this example, greenness. So line of sight. So this work, as I said before, was done with ASIA, and I think at the beginning it wasn't just for walking, but line of sight can also help us to navigate and feel more secure if there is more line of sight. So we understand that by measuring line of sight, it could impact the movement or pedestrian movement behavior. So what is exactly right of line of sight? So let's say we have road network and we have constraint. Mostly it's building, but it couldn't be just building. It could be trees, it could be fences, whatever you want, just add it to your model. And then you need locations. The locations in this case is an intersection between between streets, and other other locations such as point of interest, like restaurant, like other facility, and so on. And then then the line of sight is any line that do not that are not blocked by buildings. Based on this line of sight, we can build visibility graph. So now we just see the line of sight. I didn't add the points, the nodes, but we have here the graph of line of sight. And then we can create a visibility graph, visibility network, sorry, which is just adding more measures that you can apply on that graph. For example, centrality measures and so on. And so we built a QGIS plugin that can be used by anyone that uses QGIS, and just those who don't know that, but QGIS is open source GIS platform, and by implementing those steps, we actually create a plugin that how to calculate a visibility line of sight based on lines, based on streets, some constraints, and point of interest. And now we try to see if it works or not. Let's try to do some demo and share screen. Great. So this is the QGIS platform or software, and here is the data from OpenStreetMap, and you can see here the area of Lavoro, the street, the city center, and the university. We have the street, facilities, and buildings, and here's the plugin we developed for this goal. You just need to choose what kind of nodes you are interested in, intersection or and POI, and then you need to choose the layers you are interested, like the street, the buildings, and the point of interest. In our case, it's facilities. We have some advanced options. Usually, I just restrict my vision to be maximum 1,000 meters. And then I'm just type OK. I'm not going to do that now because it could take like 4 or 5 minutes. So I will show you the result of Lavoro. Here's the line of sight and the nodes to build the graph. So if you want to see it, just so that's the result of line of sight or the graph based on facilities and locations and intersection in Lavoro. Okay, now I need to go back. Yeah, that's it. So, and here you can see some result from a different option of graph you are interested. One is only between intersection, one is between POI and intersection, and one is only POI. For example, if you want to see the line of sight between a different location of food, there is or there isn't a line of sight between you and other food location. Maybe it's you need to do something about it. And our current project is in San Francisco, and we try to calculate or see if there is any correlation between line of sight and crashes. This is in San Francisco. Again, the data about incident crashes between car crashes in California, at least it's open for all, so you can use it. But I don't have any other thing to say about it because still we work on it. So this is about the line of sight, part of our big model of find the correlation between the factors and pedestrian movement patterns. So we talked about the urban environmental characteristics. Then we have the street network location geometry. And basically it would be easy because we have, again, OpenStreetMap. And in OpenStreetMap, the street network is very high. It has very high precision. But for this project, we need that every street would be represented by only one line. Okay. So this is Tel Aviv. And from Tel Aviv, we have a different street network. So every street can be presented by one line. What's happened in Turin, which was another place we checked, we didn't have any open source, so open data, so we use OpenStreetMap. And here is the result in Italy. Actually, it's very good result. It showed that the resolution of mapping in OpenStreetMap. So every lane are mapped into OpenStreetMap. Let's look on this image. We have here 2 lanes for cars, 2 lanes for pedestrian, and it's actually someone mapped it into OpenStreetMap, but we cannot use it. We need some simplified version, or only one central line, which say here is a street. I'm not interested in more detail. So we again develop something that can take the data from OpenStreetMap and simplify it, so every street will be presented by only one central line. And in this picture, you can see like 3 cases, or 9 cases. The first row is simple one. The algorithm work quite smoothly. The second one is also quite easy with some parallel lines that the algorithm know how to simplify it. And the last one is more complex situation. The algorithm partially failed, and that's something, of course, we have something to improve. By the idea that by using this algorithm, now we can choose any city we want, at least any developed cities, and with a good quality of network, with some few manual tuning. Okay, so that's about number 2, the street network location geometry, and the last one is pedestrian movement. So how can we obtain data about pedestrian movement? So for this, there are several options. We in the past used the Bluetooth system. So again, this is Tel Aviv. We have 61 sensors scattered around Tel Aviv, and the system record the enter and the exit of the sensor 1, and every record looks like the time of the enter to the sensor 1, exit, and to the second order, and the second sensor. In that time, in that way, you can also maintain the relations or the trajectory of the pedestrian. Or not the pedestrian, the users. Now, we don't know if it's a pedestrian, or maybe it's car, or maybe it's bikes, and we are interested only in the pedestrian. So we thought, let's look only on that area, on the middle. We assume that area will be the easier area to differentiate between pedestrian to those that are not pedestrian. So by doing some calibration, we calculate the length between each sensor, and then we can calculate the speed, and by using speed and the speed or average speed, we can at the end of the process detect or can say for every record if it's pedestrian or not pedestrian. And we got to accuracy rate of 90%. Based on this work, we look on how the government policy at the beginning of COVID-19 pandemic was affect the pedestrian movement in Israel. And we saw quite high correlation between the restriction of the government on the behavior of the pedestrians. We also see this movement, see difference between commercial area to industrial to a residential area. On the other hand, we saw that the COVID didn't change the location where people used to work. So this is one option using Bluetooth. Other options is laser scanner, and here we'll see a company called iStreet, and in that time it was completely free. It's not free anymore, but partly free. And they have many laser scanner in Germany and Belgium and Denmark, and no, Netherlands, sorry, and Denmark. And so you can see here streets with laser scan. So every person that crossed the laser scan or the laser beam, so counted. So if you open their dashboard, you can see the number of people that walk until the current time, compared to the total number, or compared to the average total number in that time and till the end of the day. And another option is, and this is quite, let's say, okay, another option is using machine learning for predicting pedestrian based on data we have from other cities. What I mean by that? So in that time, we did a research about something completely different, about giving index for different boroughs in London. Index about what? About accessibility for blind pedestrians. And we learned that pedestrian movement is something that they take into account when they decide where to go or from where to go. But we didn't have any information about what is the pedestrian movement, what is the pedestrian activity in London. So we thought, okay, but we do have data from Germany and from Israel. So let's try to build machine learning that take this data with the environmental characteristics and build a machine learning model that can be then applied on London. And here's the result from our machine learning with some high volume of pedestrian activity in the middle of London, and some local high activity. And we did compare it with the data from TfL, which is a Transportation for London survey. And it's quite similar, but the result is like 0.5 person correlation, which means we have a lot of work here to improve that idea. So the idea is good, but we still have, we needed more data and we need more, maybe more characteristics. And okay, I will talk about later at the end of the lecture. So this is another way to calculate or to predict pedestrian activity volume. So, okay, so we talked about every component. So what's today? So basically, today we tried to talk about how, and we published a paper a year ago. In that paper, we have all of the data, all of the factors, not all of them, part of them, mostly the one that easy to get, and also the pedestrian volume. And we try to answer the question of how. So from this table, you can see, so we use something called a decision tree. And the reason we use decision tree, because decision tree is one of the few that not only predict or classify data, it's also allow you to see how the prediction has been done by looking into the branches in the tree. So here first you can see the features that are most important, and as other research shown, the centrality measure are the most important one. But then we have the temporal one, like daytime, season, day type, and then all the rest of the features. As I said before, we also try to look on the decision tree itself. This decision tree includes 61 levels. Here you have only 6 levels. And the idea is to find branches. This is called branch that have that lead to a decision point with quite high number of samples with high certainty of the prediction. So this table shows us so in that case we have 5 level of pedestrian volume, from 1, which is quite low, to 5, and this table shows us for each level the branch that give the highest, the combination of highest number of samples with quite high certainty in the prediction. So we have it for each level with the feature in the left side. And we can see from here that there are features that appear in every level. So the prediction are, let's say the prediction for this type always require closeness, always require proximity to parks, and there is also a religious amenity and socioeconomic level and so on. There are some features that appear only for low walkability level and walk level, and some appear only in the higher one. And I can talk more about it, but let's continue to the end. So this is my last slide. And what next? So first, I show you some algorithm about line of sight, about the simplification of the data. So of course, we want to optimize this existing algorithm. The idea of predict pedestrian movement based on other cities, we want, again, to expand this idea by using more cities and more data and see if we can create reliable model. As I didn't, in the current work, we didn't add the physical feature, which is harder to calculate, and it require, as I said before, like deep learning and high resolution images. So that's something we really want to add. And in addition, instead of talking about specific street, we want to build some kind of profile of streets that they have the same characteristics and quite the same pedestrian level activity, and see what we get. And in that way, we can suggest where more improvement should be done and where not. And finally, we want to compare between cities. So maybe some cities, different characteristic impact pedestrian activity toward compared to different city. Yeah, that's it. Oh, no, this one.